Okay, I don't think I have anything. All right, as you are getting out your notebooks, couple reminders. Tonight, midnight. Tonight, 11:59 p.m.
Yes, sir.
4 days parts of a tire.
Done.
That is due.
It's done.
As soon as you hit the submit button, you're good to go. Okay? So you can hit that submit button at 11:58 p.m. tonight. You're good.
Are we still on tire alignment? Yeah, can
Yes.
don't need the board.
What happens at like 11:50? Just keep opening and closing it.
Yeah. I would not walk that tightrope because as soon as 11:59 p.m. hits, I am not able to go back and retroactively active allow you to turn things in. So
No, I'm not saying that guy.
I know, but I'm just saying don't play with the Grim Reaper.
So then you got like maybe like a hard messages before hard 1:59.
That's all good.
No, I already got it turned on.
That's good.
I got it done on Monday.
Now,
Who missed?
you should be embarrassed about that, and I don't even feel bad about saying that.
If it makes you feel any better, I did something like that at hockey
Let's
this morning.
just place it in the trash can. All right. Further reminder that phones
Oh.
and earbuds should be taken out and put away.
You gotta put it in.
If you cannot have self-control, please feel free to put it in my little
Yes, sir.
phone
Yeah,
pocket contraption.
I think AJ has his AirPods in.
Looks like it does.
Miguel. No, Timmy does though.
Hey,
I got hearing aids.
I don't need people calling out each other. I am more than capable of understanding if you're on your phone or you're on your phone. Okay.
Hey, man, take them out.
I'm gonna take off my hearing aids, guys. Sorry.
All right. At this point in time, we got some ground to make up in regards to our alignment. So again, we're going to be continuing to take notes. I'm hoping we can get significantly further than we did yesterday. Yesterday we talked about our caster. Okay. So a couple things with the caster. Oh no, we didn't even talk about caster, did we?
No.
Oh man, we
This was the
just.
last
So
time.
we are okay. All right. Again, vocab words here. There's going to be a lot of new vocab words when it comes to this. So I wanted to find what alignment is, specifically to position in a straight line, because again, our goal, is with everything on the vehicle to be going in the same direction.
How's it gonna feel?
Okay. The reason why we do that is very simple. Okay? We want to make sure that our vehicle is going to be able to be safe when we operate it. Right? If my steering wheel is crooked and I'm going straight, there's something wrong.
Oh, yeah.
Obviously, right? Instinctually, when I'm driving my vehicle, I expect that when the steering wheel is straight, I'm going straight. It's much more predictable when I'm driving. So that way I know where I'm going and I can avoid accidents and things like that. Okay? It provides for sure handling. If I've got incorrect alignment issues, my car is not going to have the traction under braking, acceleration, or cornering. And again, that could cause me to move the vehicle to go in an area or a direction that I don't want it to go in. Okay? Third of all, by having everything in the alignment, because it's going all in the same direction, the engine has to not work as hard, which means the gasoline is able to not burn as quickly. So I'm actually saving on my fuel economy. And then finally, we've talked about this prior in our tire lecture and presentation, is it also allows us to prolong the life of our tires. Okay? The tires are rolling in the direction that we're traveling. They're not scuffing, they're not wearing, it's not causing additional friction, all that sort of stuff. Right, Miguel?
Yeah.
Okay. Those are 4 big reasons why we're going to go through this.
Nope, get out.
You got pass.
No, that's just a yellow sticky note.
That's a nice sticky note. Remember to change your attendance at the end of the hour so it's not
Yeah.
to absent.
Damn.
All right. So we talked about what alignment is. We talked about why we want alignment. So let's actually get into the thick of things. Okay, Gerlach and
What?
Donovan? Yeah.
We're actually doing fantastic.
There are 3 wheel alignment angles. Camber, caster, toe. Caster, camber, toe. That's what's written up there.
Toe.
Okay? Not only do you need to know what they're called, but you also need to understand which of these angles aligns with what it's called. So I'm going to give you a little hint on this.
Yeah.
Caster is viewed from the side.
Yeah.
The camber is viewed from the front. And the toe is looking at it from the top down. 3 dimensions. If we were in math class, we'd be talking about the x and y and z axes. Length, width, and height.
Yikes.
Right?
Why is not supposed to be?
So again, because we have 3 dimensions, we're going to have 3 wheel alignment angles. And this is what they're called. I would highly recommend also that you are drawing the picture that corresponds with what it's called.
Oh.
Okay? As best as you can. Again, it doesn't require much artwork. You're just literally doing this.
Bro.
Yeah, circles. Circles everywhere.
Okay? And then you're probably going to label it as front.
Hook some.
Okay? If I was drawing my notes, I'd draw this. Here's my tires.
And Mr. Getz, so wait, hold up. I'm gonna draw these. It may take a while. So like, can you like?
It doesn't need a while. I'm literally going to draw a circle.
No, but Mr. Getz, yeah, I'm telling you. You
There.
don't understand.
Stop talking.
What you don't understand is we don't have time for you to be in art class.
Oh.
Hey, that's not a dig.
No.
We're taking notes. Notes are meant to be sloppy. They're meant to be ugly.
Right.
Okay? Later on, you can go back and beautify it.
Timmy. That's when you need.
Caster, camber, and toe. We're now going to go through all 3 of these angles individually and talk about what each one is going to be doing, how we adjust each one, why we want to, and limitations on what this thing can do. Okay? So the first thing that we're going to be getting into is caster. Again, vocab word. You need to know what caster is. It is the forward or rearward tilt of the spindle as viewed from what side? The side. Okay? We first obviously want to identify where the front of the vehicle is. There's the front. This is the direction that the vehicle is going to be driving in. Okay, I can tell because I've got headlights there. That's usually a dead giveaway. Okay? Tail is too far back. Takes up too much room. Now, we've got 3 different positions that the caster can be in, or the caster angle can be in. If I were to draw a dot at where my shock absorber, strut, or suspension system is mounted onto the chassis of my car, and I were to draw a dot in the center of my wheel, and then I were to draw a line connecting those 2 points
Should be 180.
in comparison to where the contact patch of the tire is, if it's all straight up and down, vertically, perpendicular to the ground, this is what we call neutral caster, or 0 degrees. Yes?
What the changes in the caster affect? How
Well-
do they affect the car's hand?
We'll talk about that.
Okay.
Yeah. Good question. Good question. Because it does affect the car. It really does.
I think I know that one.
Okay?
Sim racing sim.
Yeah.
I think I know.
Yeah. Now we're going to get into some education that's actually worthwhile, because that will change how you drive a car on a racetrack. Now, again, if we keep that same vertical perpendicular line to where the ground is at, this one's going to be a little weird to kind of wrap your head around, but just follow me for a second.
Yes.
If my mounting point for the top of my suspension, is in front of that line, when I go to draw my line through this object, where that line actually intersects with the ground is behind the contact patch of the wheel.
Really?
Because it's behind the contact patch, it is negative caster. Okay? Even though the front or the top of this is forward, the line is behind. That's why it's negative. Okay? The opposite of that is also true. Again, if I've got this vertical line going through this imaginary place where the contact patch, the tire, center of the tire and the road is, if I move the top of my mounting position for my center of the suspension and the center of the wheel, and I were to draw this line through, this one's actually going to go in front of that contact patch on the tire. This is positive caster. So we've got negative caster, neutral caster, positive caster.
So it's just all based on where you place the spring?
Yes. Now, there are varying degrees of angle, just like a protractor, on my caster. I can have negative 10 degrees, I can have positive 10 degrees. It's an arc that rotates around the center of that tire. Okay? But when you go on an alignment machine, and we do all of our adjustments, and I wouldn't say adjustments, but calculations, the computer is then going to find the angle, and it's going to tell you negative or positive degrees, and that's going to give you an indication of, is it slanted this way or is it slanted this way? Now, this is something you're going to want to write down in your notes. I'm going to say 99.98% of cars have a positive caster. Okay? I can't think of anything off the top of my head that would have a negative caster. Okay? Neutral would not be ideal. We're going to want a positive caster. Okay? Also, something you're going to want to write down in your notes. I got to be very careful how I word this. Okay? Under normal stock conditions, caster is not something we are able to change. Okay? The caster angle is set from the factory. Now, with that being said, there are aftermarket pieces of equipment that you could install and modify your car in order to change your caster angle. But for pretty much every vehicle that's going to be on the road, that is set and it's not able to be changed from the factory. Okay, it's important you know that. So anyways, negative caster, neutral, positive. Every car is going to have positive caster and it's set. Okay, we still want to measure it because it's going to be important that you understand something here in the future. I haven't gotten to it yet, and it's actually quite interesting. Okay, again, this is just another kind of illustration of what caster looks like. Sometimes you might not have a car that's drawn with the wheel or angle. In this case, we'll have an arrow pointing in the direction that the car is going to be traveling in down the road. Okay? Just so you are aware. This is just a different way of writing it. Now, here's something I gotta correct because this picture is wrong. That's not positive, and that's not negative. This is actually positive, and that's negative.
Why did you do that?
Okay, I don't know why this picture incorrectly identified the caster.
Okay.
Okay.
Jeez Louise.
I'm thinking it's probably because they're thinking that because it's forward of this, but that's not where we're looking at. We're looking down here, and that's behind the tire, so that's why it makes it negative. This is in front of the tire, that's positive. Okay, but again, we're looking at this fictional line that's being drawn, and again, that intersection is going through the center of that axle. Okay. Now, one thing to keep in mind, caster is not a tire wearing angle. Write that down. If I'm going to go inspect my tires out in the shop, and I'm noticing that one side of my tire or something, a tread of my tire is wearing down, it's not because of the caster angle. Okay? that will never cause, I wouldn't say never, but it will not cause tire wearing conditions. Okay? I can't say that about the rest of our alignment angles, but for caster I can. So whenever we're trying to do our diagnostics, whenever we're trying to figure out what's wrong, usually caster is something that we can kind of put to the side and go, okay, let's focus on camber and toe. That's more likely the culprit. Also, fun fact that you probably may or may not have known, but roads are not flat.
Yes, they are. Oh, they are.
Right?
So by
Keep in mind that when you're driving down the road, it feels like they're flat, but they're not. Civil engineering and all this sort of stuff, right? They actually have essentially a slope to them.
Water.
Okay? And the center of that road is essentially the peak of that slope. And again, the reason why is because, as you have correctly identified, when it rains out, we don't want water pooling up on our road, because then you're going to have to obviously drive through it, which would not be good. So we want to actually have a slope. It does not need to be a huge slope, but just enough to allow water to run off and go into the ditch. So that way, when we're driving, we have the best traction possible on that road. But because there is a slope, if I were to let go of my steering wheel, theoretically, right, that car is going to want to also go into the ditch just like the water does.
Yeah, you just gave me an idea. No.
Donovan.
So why does my car, or my truck, when I put on the brakes, it veers off to the...
It's most likely you have a frozen caliper piston.
When I moved, I took them all apart and did all that, cleaned everything up, moved them.
One of your pistons is probably getting stuck. Most likely. That I can't definitively say that, but that is an age-old sign that your piston is not pushing on one side and it's gripping on the other side, which means it's slowing down this tire, which then it's pulling it off. Now, is it doing it under braking, or is it when you let go of the brake?
Well, it pulls to the right a little bit.
Okay.
I need alignment.
Could be.
But it pulls significantly harder when I brake.
Yeah, it's with your brake.
And then I just replaced the caliper on the driver's side.
Okay.
I thought that was the issue. Obviously wasn't, I guess.
No. Could be maybe you have, it might not be the piston that's frozen, it could be that your brake line might be restricted. So when you push, the pressure from the brake fluid's not getting into the piston.
Okay.
That's something you might want to look at.
I also have really spongy brakes.
Air,
I have to push it
100% air in the system.
I don't have the air. There's no air.
There's air in the system.
I've done it multiple times. There's no air.
There's air in the system. You got spongy brake pedal, it's air in the system. When you bled your brakes, did you also bleed your ABS?
Yes, I did.
Okay.
Multiple times.
There's still air in there. All right. Anyways, thank you. We'll get into the brake stuff fourth quarter. Those are going to be that's going to be some good points that we're going to want to talk about fourth quarter. Anyways, because there is a crown in the road and it's sloped, when I let go of my wheel, which you shouldn't do, by the way, but if I were to let go of my wheel, my car, I still want to go straight down the road. So how do I offset that crown, that slope? Because normally, if it would want to go into the ditch. Well, the reason's very simple. We're going to have different angles. Do I even have this on here? We're literally going to have a different caster angle on our passenger side than we are going to have on our driver's side. Okay? We can literally manipulate our alignment to offset for that road crown, so it still allows us to drive straight without going into the ditch. Okay? And the reason for that is this little asterisk right here. A vehicle pulls toward the side with the least caster angle. Yeah.
So why do I see some cars or trucks dog tracking, or crab walking or whatever.
It's probably because the thrust angle is incorrect. That would be my guess. Well, we haven't gotten to thrust angle yet.
Okay.
We'll get there. Okay, we'll get there.
Your toe is jacked.
All right. By the way, write that down. Important. A vehicle pulls towards the side with the least caster angle. So again, let's pretend my driver's side and my passenger side. Let's say my passenger side has -10 degrees caster. My driver's side then might have -12 degrees caster. Normally, a person would say, hey, if I want the correct alignment, I would want the same on my passenger side as my driver's side. But again, because the vehicle pulls towards the least side of the caster, this is lower than this, my car is going to want to naturally drift left, the driver's side, yeah? But guess what? I have the correct amount of degrees there that is going to pull left while the road is pulling me right. So it literally kind of counteracts each other, and by doing that, we're driving straight.
Oh.
You know what I mean?
Yeah, we'll let you put.
Because there is a standard on how roads are made. The manufacturers already know what that angle is, and thus we can build it into our vehicles. Kind of interesting.
So every road's supposed to have like the same angle.
It's supposed to be, yes. Now again, that's not a huge slope, so this difference here is not
Yeah.
a ton. But I'm just saying, when we go do an alignment check out as a lab, you're going to notice that these are different, or they should be, and that's on purpose. Don't try to get this to be the same, because then your vehicle is going to start pulling. You go, wait a second, I just did an alignment. Yeah.
Does the computer or whatever automatically do the difference, and then like you're supposed to set it to exact middle or whatever? Or do you have to figure out the difference in the caster or not?
Okay, that's a fantastic question. The computer out there is programmed with the manufacturer's specifications of what angles that the manufacturer wants in it. Okay. That doesn't necessarily mean that it's always correct, right? So that means as a technician, I still have to know what's going on here. So that way, if the computer gives me faulty information, I could be like, no, you're stupid, computer. I'm going to do it this way instead. Okay? It's the same thing like if I do a Google search, right? AI comes up with something. You can read it. As long as you're educated enough to understand what's going on, you can read it and go, that's not what I was hoping for. I was thinking about something else. Okay? The computer's not always right. Okay? All right, little pop quiz here. This is not obviously a Plickers card, although I probably should make it a Plickers card.
Yeah. Please.
Think about it for a half a second. But what type of caster is this?
Positive.
We got 3 options: positive, neutral, negative. Just think about it for a second.
The headlights on the other side.
No, it's till.
Hey, is it nappy time in here? Wake up!
Shh, Tim, it's not your job to wake up.
It's positive.
Take
though.
those
They
AirPods
have
out.
to-
Okay.
AirPods in.
They definitely do.
Who's positive?
What do you think, Jesse? Positive.
I'm pretty positive that that's positive. Yeah, I'm pretty positive.
Yeah.
Stop
are
being
such a
stop
funny
being
guy.
so positive.
Whoa, what the heck?
Alright, I'll just be negative.
Because you're wrong.
Again, we always start here in the center of our axle or our wheel hub. This particular suspension system is mounted up
Did I
here.
just see you hit him?
Here is my theoretical vertical line where it intersects with the ground. That's my contact patch. This is forward of that contact patch. It's positive.
That's a vertical line going horizontal.
Well, it's horizontal and vertical.
Hey, that's the right triangle.
This is it. Crazy, isn't it? So we can actually know the degrees by the angle. So, remember, this is the front of the car too, so it's driving that way, so it's passenger. You guys all right?
I
No.
don't think they are. I really don't
Yeah, I
think
got
they
you.
are. I think you need to contact medical support.
Maybe I do.
Right here.
Let me.
Why would I joke?
See how does that return to a straight line? Because that's
I think I know this one.
Tuck A change it just the other way. Everyone, I'm not doing this problem.
What about me?
All right, there we go.
I'm thinking,
Dave.
My order is different than what
Yeah,
I
what
got
is it?
here. All right, so
G.
listen carefully here now. A car's steering wheel does not return. Oh, we didn't even talk about this.
I was gonna
fine.
say.
I already know
fine.
the answer, guys. It's
It's
fine.
fine,
Yeah,
it's
guys,
fine.
Yeah, I know the answer.
Yeah, we know the answer.
Yeah, we supposedly know the answer.
You can't change the caster.
Can we get little?
Yeah, you can change.
All right,
Can we just guess?
we can guess. Sure. A car's steering wheel does not return to the straight ahead position after turning. Tech A adjusts the automobile's caster angle. Tech B says the car's caster angle has nothing to do with this problem.
I know the answer.
What is it, Timmy?
Yeah, Timmy,
It's your mom.
don't get it
Stop.
Timmy, you're
Did I even get the right?
grown ass man, by the way.
Timmy should put his phone.
This is not right at all.
Timmy's kind of offending me right now.
Let's do a public.
Because the caster angle's like this.
Let's put Timmy in those things and we throw tomatoes in them.
So was it?
You are so
so
freaking funny, man.
Is
That
it
was
good?
hilarious.
Did you get me?
Shut up.
I got you.
Ugly ass middle party.
Hey.
My bad.
All right, I got you guys.
Bro,
Cameron,
we're so ugly.
I got you.
Rubber for a turn.
All right.
Be quiet.
Huh? You get me?
I got you.
But
You're
Timmy,
What do we
the
get?
card isn't even. Timmy.
Okay.
Stop,
Timmy,
guys,
Stop,
stop.
stop.
Guys, no, we should not be playing.
What do we get, Gatsby?
The reason why I didn't cover this.
No, no, no.
The reason why I didn't talk about this is because I thought I already did talk about it, but
Oh, no, you're good.
this was first and fifth hour that we.
So how many of us got it wrong?
Most of you.
What was it? What's?
It's okay. So here's the deal. As I'm driving down the road, you've probably encountered this before, right? Where you're making a turn, you make your turn, tires turn. Okay, I'm finished done making my turn. After you're done with the turn, or as you're almost ready to complete your
turns
turn,
back straight.
what do you do with the steering wheel in your hands?
Let go.
You just-
Right, you
kinda, like,
loosen your
slowly.
grip. You don't take your hands off the wheel, obviously.
I do.
You loosen your
He does
grip. What does the steering wheel do?
Return back to
going.
center.
Returns back to center.
Yes.
Okay.
Yes.
Why does it turn back to center?
Because there's resistance in
Power
return. It goes to the
steering.
direction with least resistance.
It's not power steering.
It's realigning.
It's realigning to go straight again
Momentum.
Because
Right.
there's less resistance.
because the car has a positive caster.
So what would be neutral?
So that's the idea behind having. That's
Like the curve.
that's the reason why we want positive caster on our wheels. That's why every car is going to have positive caster, because the car is literally pushing the tire. So as you turn, right, it's pushing it, so it's going to push it back straight again.
What will if it's
Okay.
like neutral?
So neutral, I mean, it will, but it won't obviously do it.
That's
Well, I would say if it's neutral or negative, it's not going to do that. Okay, think about a shopping cart. You ever been to Walmart or Festival Foods? You get a shopping cart.
I always get the broken one.
What? Yeah. What are the wheels on the shopping cart called?
Wheels.
Wheels.
Rubber.
Tires.
They have a very particular name.
Bearing.
Do you know, Hunter?
No, I was gonna ask, did you want A or D?
I'll get that here in a second.
Oh.
Okay. What are the shopping cart wheels called?
Wheels. Shopping for shopping.
Hey Siri.
No.
Where are we getting at? Guess?
Bearings.
Yeah.
Yeah, I guess.
You guys don't know what the name of the shopping cart wheels are?
Yeah. Shopping cart.
Plates? I don't know.
What were you talking about?
Give us a hint.
They kinda
Okay.
get the
No, give us a
roller-
hint.
This might listen. Stop. This might blow your mind a little bit.
What are they
Okay.
called?
The wheels on the shopping carts are called casters.
What?
Oh, yeah.
Whoa.
Stop acting like you do that.
No, I did. I didn't know that.
What kind of caster does the caster wheels have on a shopping cart?
Negative.
Positive or negative?
Positive.
Zero.
Neutral.
Natural.
Yeah,
Neutral.
negative caster.
Told you.
Damn it.
So if my arm, right, this is where my caster wheel is mounted on the shopping cart. Here's the wheel, right?
Really big.
Now this wheel is literally following where this is at on the shopping cart. What is the most annoying thing about shopping cart wheels?
When it's
When
like
the
When they
rubber's broken
spin.
on them.
when it's like
When
uneven
they're
and
broken.
it just keeps like.
Do you ever notice shopping cart wheel just kind of flutters
Yeah.
as you're pulling along?
I threw mine at the register.
Guess why that does that?
Because the
Negative
bolts are
caster.
bolts are loose.
Because of negative caster.
No, the
So
bolts are
you're
loose
telling me
on
if they
it.
just put the things on the other direction?
Well, the problem is it's set up for a negative caster. But if you were to put it as positive caster,
That's it.
it wouldn't follow very well.
That's, trust me, it's when the bolts are loose and there's no rubber on it. I work in a grocery store.
There we go. But here's the deal. That's why cars have positive caster, because then it pushes the wheel to go straight again. Okay?
What would the one that's?
If we had negative caster on our cars,
So is there any
we could
benefit?
potentially have the same wobbling problem.
Is there any benefit from negative or neutral test for them?
Not for a car. Actually, there's very large negatives to
What
it.
do you mean not for a car? Like what's the exception?
Why is it an option?
Yeah, why is it?
What's an option? It's not an option. It's positive caster. We use positive
So you
caster.
said not for a car.
We're
so-
going over this.
Right.
What
For a
is
shopping
it?
cart, negative caster.
Oh, okay.
Right, but not for an automotive application.
Is that like something that cause like a motorcycle, like a death level? Where the whole tire just starts shaking? Like,
I think that might be something else. Because a motorcycle's gonna have positive caster too.
What if I hit a really big pothole now I have negative
Alright.
caster?
because also like when you're driving, like on a motorcycle, it just starts, the front tire just starts going.
Yeah, motorcycle's not my thing, so I wouldn't really be able to. Yeah, I know.
Adrian has a
Anyways, Gerlach, that's a great question. I'll answer that later. Or an observation, right? Hey, I hit a pothole, and now all of a sudden I've got negative caster. You can hit a pothole as hard as you want. You're not going to get negative caster, but you can change other things, which are going to adversely affect the vehicle. Anyways, getting back to this. Tech B says the car's caster angle has nothing to do with this. Tech B is incorrect.
Let's
Okay?
go.
Caster has everything to do with the car's steering wheel returning back to the straight line. But as I talked about previously, the adjustment of the caster angle, we can't change that.
So
it's
it's
from the
weird.
factory, okay? But
Break.
at least Tech A understands that, even though they're going to want to change or adjust the caster angle. So
He's wrong.
yeah, we wouldn't adjust the caster angle.
So it's
Okay?
So it's not.
Because you can't.
So it's
It's the big D.
So theoretically speaking, it's D. Although I have Tech A as the correct answer in this application. I might have to change that.
You definitely change that.
All right, we talked about caster. Let's talk about camber.
Positive camber's looking a bit scary.
Here, I'm gonna be. Shh, Miguel.
Those rims are about to smack.
In my teaching experience, every time that we talk about wheel alignment, we talk about camber, most students probably understand this wheel alignment angle or understands it is a wheel alignment angle or what it is, because in car culture,
We got riced out companies.
no. Stop, guys, just shh. In car culture, it's very common to have a stanced out car, right? I get a car, I'm going to try to slam it onto the ground as much as possible.
On the side.
In order to do that, I have to change the geometry of my suspension, and the only way I can get my tires to fit in that is to literally camber the tires so it drops the car ride height. Okay, so now I'm running around with my cars like this to lower my ride height. Okay?
Or you get the squat
Now.
trims.
The thing with this is, as an automotive instructor, I see that and I cringe. Okay? And the reason for that is because they don't. I don't want to say they don't understand what they're doing, because they do, because they're replacing their tires probably
Every 2 days.
yeah, exactly. Okay?
Driving on the sidewalls.
So it's kind of one of those things where it's like, you guys are lowering your car, it looks cool, your car's not performing at all.
Doesn't that put
Okay?
like a lot?
You're driving very slowly in that case.
Doesn't that put like a lot of pressures, like almost like on?
Not the sidewall. What? We'll talk about it. Anyways, Donovan, you had.
What is it? Are there any like benefits to doing that? Or
Big
is it
tires.
just
To it, not
Okay,
to there,
so-
not to that big of an extent.
Well, first, before I answer that question, let's talk about what this is, because in some applications there are, to some degree, okay, but not for vehicles that you're going to find driving around Fond du Lac.
You can find negative
I have a buddy from Fond du Lac that has a negative camber.
Fun. All right, what is camber?
Camber.
Camber is the inward or outward top tilt of the wheel and tire as viewed from the front. Okay? So here's my headlights. Here's my grill. Okay? So I'm looking at it as if the car's going to come and run me over. Okay?
The car looks goofy.
Again, if I have a theoretical vertical line, or my car just looks like it's crying, and I were to take where this suspension system is mounted, or I shouldn't say the suspension system, the top of the tire, and where the center of that tire is again, and I'm literally drawing a line, okay? If it is on the outside of that theoretical vertical line, it's positive camber. At the same point in time, if I take the top of that tire, go through the center of that tire rotationally, and the top of that tire is tilted inward, it's negative camber.
Get off your ball.
At the bottom of the tire is tilted inward, it's positive. Because the definition of camber is we have to look at the top of the tire. Okay, it's not where the bottom is at, it's the top.
It was just bottom on the caster. Why not just keep it all
Wait.
bottom?
Because we just want to confuse you.
Mr. Getson. Mr. Getson.
I don't make this up.
May I look at something on my phone that revolves around this?
Not in class. Maybe during passing time. Okay, so positive, negative caster. Now I will tell you this.
Get him out of here. Check this one.
Just like how we have different caster settings on driver's side and passenger side, most vehicles, depending on if we have front wheel drive or rear wheel drive, actually no, hold on a second, that has to do with tow.
Oh.
There might be a slight difference in camber.
Between the front and
No, just on the vehicle, there might be a little bit of negative camber. But again, that's not going to be a lot. Typically, we don't see complete neutral, although neutral is fine in this instance. There might be a slight negative. But again, we're not going to over-exaggerate that.
So there's no neutral camber?
No, there is neutral camber. That's just straight up and down. Ideally, we would want neutral camber.
Yeah, that's what I was.
Okay.
Joe.
Okay.
Oh, yeah, there's neutral camber.
Unlike caster, camber is a tire wearing angle.
Yeah.
Okay? So we have to ask ourselves, where does the tire tread wear out if I have misaligned camber?
Depends on the camber.
It depends on positive or negative camber. Okay? So I don't need any sophisticated tools. I can probably make an educated guess based off of what I know about camber and its angles and where the tread is wearing out.
Tread pattern.
Okay? Tread pattern. Now, if we really think about this, neutral camber or zero camber, the tread is evenly across that road, theoretically.
So it should be.
Okay? Which means all tread is wearing out as evenly as possible across the whole tread. That road is still going to remain flat. What's making most contact on my tire tread in positive camber?
But Mr. Getson, the road is flat.
I know, that's why I'm saying
No,
theoretically.
the outside.
Sidewall-ish, kind of,
Outside.
like the cone.
The outside of that tire tread is going to be touching or making contact with that road more often, more frequently, which means I'm creating more heat, more friction. It's going to wear out sooner. Okay? So again, outside tire wear is an indication, potentially, not always, because it could be other things, positive camber typically. Okay? Negative camber, same concept, right? But this time, instead of on the outside of the tire, negative camber is indicated by inner tire tread wear, more so than any other place. Okay? Now, not only are we putting additional pressure on the inside or outside of my tire, but it's also grossly wearing out your wheel bearing because you're added more lateral loads because your whole wheel bearing is crooked as well. So now this is operating as the wheel's turning in a way that was not designed to do. Okay, so not only are you replacing tires every 2 days, you're probably replacing your wheel bearing much, much more frequently. So this is another reason why we want to make sure that things are aligned. Okay. And again, to recircle back around to our alignment, I don't have as much traction on the road, so my braking is going to be longer, my acceleration is going to be longer, my cornering is not going to be as efficient. So the handling is not as good.
And that's you can say bye-bye to your tire.
Yeah, and plus you're saying bye-bye to your tire, wheel bearing, and potentially other stuff too. Okay, now, Donovan, you asked me, is there any benefit potentially to having a set camber that's not neutral? The answer is yes. If I'm in a race car, like let's pretend Formula One, and I'm going 100 miles an hour around a sharp corner, right? I'm going to have negative camber on my front wheels. Okay? I'm purposely going to tilt my wheels to have negative camber. That way, as I'm cornering, the full tread is actually making contact with the road and pushing on the forces in order for me to make my turn. Okay? So I'm literally manipulating the angle at which I'm doing that to be able to go faster. That's all part of the setup of the car. They go to this racetrack and they say, okay, if we change the negative camber to -5 degrees instead of -10, how does that affect our grip? How does that affect our speed? Gorilla.
Why'd you only say the front tires?
Because the front tires are the ones making turns.
I know, but what happens if you're going around the corner fast enough and you lose the rear? Wouldn't more negative camber in the back help keep that grip in a way?
To some degree, yes.
I think I know that word.
But
He's
you're
on
gonna,
this car.
you're gonna get me on a soapbox here. So most drivers, good drivers, steer with the pedals, right?
Yeah.
So if I'm manipulating my accelerator, I want as much grip on my back wheels
Yeah.
to be able to rotate the car. So I'm not necessarily as camber's not as impactful on the rear tires because I can accelerator slow those down
Yeah.
with contact patch. Where the tires, because they're making a turn, the first part to enter the corner, they can hook around. Plus, they're not going to wear out or heat up as much. There's a whole bunch of stuff on that for the setup. Rear tires are typically larger. Yeah.
Do you think we could ever use cars like how the Flintstones did?
You're welcome to try. I would be on top of a hill though. Donovan.
What about NASCAR tires? Or NASCAR and stuff like that?
Okay, so yeah. If you talk about like NASCAR or even like your late models or even dirt cars, if you ever notice that, obviously, right? They're even tilted.
Dirt cars are tilted off.
Yeah.
They're like drifting though around the corner.
Pretty much.
Well, that's what dirt.
But
though.
that's right. That's the whole idea behind dirt. So NASCAR setup is similar to that too, because guess what? You're only turning left.
Yeah.
So guess what your setup's going to probably do? You're probably going to have a different caster for sure, and you're probably going to have different camber angles from the passenger side even to the driver's side, because one side's going to be higher up on the banking than the other.
Negative and positive.
And you can manipulate those wheel alignment angles to literally have the steering wheel straight, and the car's going to want to go turn left. So then when you're on the straight, you're actually turning right to go straight. It's kind of a wild thing, but yes, 100%. You're right on the money with that. That's why they pay the race engineers to kind of mathematically calculate, okay, this is the ideal angle for all this sort of stuff, and there's a ton of geometry, trigonometry. The amount of math is ridiculous in this stuff. Okay, one thing I do, again, I want to kind of get this in here. A vehicle pulls towards the side with the most positive camber. The vehicle pulls to the side with the most positive camber. That is in addition to the vehicle pulls to the side with the most negative caster.
Casper.
Okay. So there's a slight difference there between the two. Positive camber gives you pull, negative camber gives you the most pull.
And what with Casper?
And guess what? You can compound those problems, or you can cause those to neutral each other out. Kind of crazy, huh,
What do
girl?
you mean, like, what do you mean by like neutral? Like have one positive and then one negative?
You could have, yeah, because I could have one side have more negative caster, which means, oh, my car's going to pull this way, but then I could offset that with different camber, which then it kind of offsets one another. And again, that's just manipulating the car. It's manipulating the tire wear, the whole 9 yards. So again, I'm just giving you guys information
There's 9 yards.
without necessarily giving you the full like brain melting calculations, because when we go do an alignment check, we're going to allow the computer to measure those angles for us, do all the calculations for us, and then gives us the information, and we just have to interpret that information. Okay? All right. Let's see if I'm hoping I talked about all this information. Tech A tilts the top of a car's steering knuckle toward the rear of the car to adjust for positive camber. Tech B tilts the top of the tie rod toward the front of the car to adjust for positive caster. Who is right? Now, unfortunately, there is some missing information because we haven't gone through our suspension system yet. So you might not necessarily know what a steering knuckle is or a tie rod.
I know what they are.
Okay. Without necessarily giving you any information or any answers, understand that the steering knuckle is where all of your steering and suspension components mount to, including the wheel bearing, the wheel hub, your brake caliper, your shock absorber, coil spring, lower control arm, maybe an upper control arm.
What about the tie rod?
Okay, tie rod is also going into the steering knuckle.
Oh, yeah.
Okay.
I know that.
I needed it.
The tie rod is essentially a component of your steering system that pushes the steering knuckle in or out, which causes your tires to move and rotate to turn. Okay. Hopefully with that little bit of information, you may be able to deduce.
It's B.
Yeah, bro, it's only.
Ow.
It's actually D.
That's J.
Jay, I like that answer.
I'm doing A. I'm going A, guys.
Timmy.
Did you lose it, Gaskins?
I don't think I know this question.
I'm just kidding, I'm going C.
What the frick?
What the Sigma? Say that, not the
Alright, shut up,
break.
Timmy.
Okay, shh.
What the hell?
Oh, no, here it is. Okay.
Uh,
I'm pretty sure this is the
Do you
question.
get me, Mr. Getzky?
I got you.
Alright, thank you, Mr. Getzky.
are you sure it's
What
not
do
the
you
last
mean?
one?
Gotcha.
Let me higher.
Hey.
All right, got you.
AJ caked up.
Yep.
Me.
Green light.
Oh, your finger's in the way, Miguel. There you go, I got you. Yep. All right.
That was my ring.
Ding, ding. We got 2 minutes.
40%. What did you got to do?
Well, the correct answer is neither of them.
That's how I was gonna put it.
So,
What?
But she did it.
top of the car steering knuckle toward the rear of the car to adjust for positive camber. So you're actually you're adding more positive camber. That's not a very well worded question.
See, you tricked us.
I didn't trick you.
tricked
Tech B,
us.
listen, for sure 100% Tech B is incorrect because you can't really tilt the top of the tie rod. If you do, you're just rotating it, which isn't affecting anything.
Sounds like you're bending the tie rod.
So,
Nike is.
not really bending it.
Are you kidding me? My battery is put at 99%.
nurses?
They could've charged
If you
up
got a
mine.
pass.
Wait,